Hi buddies, good morning. In the previous lecture, we have designed the Turing machine for computing 2's complement of any number, 1's complement of any number, and fn is equals to n minus 1 and fn is equals to n plus 1, like that. And today I'm going to discuss Turing machine for some computing functions like fx comma y is equals to x plus y, right? Or fn is equals to 2n, likewise. So in this situation, just you can see here, how can we construct the Turing machine? So the function, that is the additional function, you can say that function can be used to add two numbers. So how can we construct the Turing machine for that function? So the purpose is, in this situation, these numbers are given to you, means x and y are given to you, and now you have to perform the addition. This is the actual problem at the time of constructing this particular machine. So now, how can we represent all these things? How can we solve the Turing machine? Just see here. Suppose this is the input tape, and these are x, and now we will use a separator here that will separate the values of x and y. And now this is suppose your x, and now y is suppose this one. And after that, you will find the blank sign as usual on the Turing. Clear? So now the objective is, this is suppose your x and this is suppose your y, and this 0 is what? 0 is the separator that is used between these x and y, and it represents that x is the before 0 and y will be after. Just 0 will separate these two values. So now the point is, how can we construct a Turing machine that should reflect you the addition of two numbers? So now, if I talk about the numbers, then if suppose first number is 5 and another number is 2, and simply the answer should be 7. But in case of the Turing machine, we will use the unary number. We will prefer the unary number. That means in case of 5, so just you should write in that form. This is the simple representation in unary format for decimal number 5. Similarly, for 2, you can represent in the format of unary number, that is 1, right? So total, this is suppose 5 and this is suppose 2, and your answer should be 7. That means 1, 2, 3, 4, 5, 6, 7. It should be the answer displayed on the tape. So this is the basics about the construction of Turing machine. Now the point is, why we are going to use the unary number. So always we will prefer to the unary representation because it is easier to manipulate with the Turing machine. So just try to visualize the things in your mind. Just see here. Suppose this is your x 111 in the form of this one, and 0 is what? 0 is the delimiter or the separator that separate two numbers, that is x and y, and simply y is also represented in the form of unary number, and last at end of the y you will find the blank sign as usual we will use in case of Turing machine. Now the finally what we have to do, just see here, just our objective is just to eliminate this one, right? So that we can just concatenate these two numbers and we will find the addition of x and y. But the point is, how can we eliminate this number? This is this separator delimiter 0. So this is the important point here. So just we will try to find a logic in such a way that this 0 is converted in the form of 1 and this last one is converted into the form of blank. This will be the logic. This will be our logic. Then we will just combine this x and y. For example, x is suppose 2 and y is suppose 1, and separator is 0, and after that it will be blank here, right? So how can we find? Just see here the execution part. So our objective is just try to convert this into 1, right? And try to convert this one into the blank. So your answer will be display on the tape will be 1, 1, 1. That is 3. So it is our correct answer. So this is the simple logic behind the construction of the function fx comma y is equals to x plus 5. So finally, you will find the answer in that format. So now just try to construct the Turing machine in this way, that as I already told you. Suppose this is the x part, this is the separator, and this is the y part, right? So now just see here how your machine can work. You are in state q0 initially, and now 1 is you are reading from the tape side. Just you are writing 1 and moving towards the right. This is on the loop. That means all the 1, you don't need to change any 1 into any other symbol. Just after reading 1, you are moving towards the right, simply because it is on the loop. So no problem. You are again in the q0 state, and finally you will find here the separator on q0 state. So in this case, just you are converting it into 1. Just see here. So just this 1 is converted into 1, 0 is converted into 1, that separator is converted into 1. Now you are moving towards the right direction. Okay, and now the state is q1. So just see here, you are in state q1, and now in state q1 you are getting this 1. So this 1 is converted to 1, just remain the same and move towards the right. So just you are moving towards the right. And finally, after the end of the string, you will find the blank sign as usual we use in the case of the Turing machine. So if you find the blank sign, just read the blank, write the blank, and move towards the left. And after reading this blank sign, you move towards the left, and direction is left, and the state will be Q2. Clear? So this is the representation after moving towards the left direction. Now you are in the Q2 state, and now after the moving towards the left, you will find this blank sign, and you will find this 1, and this 1 is the last one of your input alphabet. So just convert this, read this 1, convert it into blank, and move towards the right. On now you are in state q3, and if you directly find the blank sign here, that means you are in final state. So this is the simple representation for simple construction for fx comma y is equals to x plus y. So this is the simple way to add two numbers, to compute the two numbers with the addition function by using the Turing machine. So now again you can focus by some execution, by some animations. Just see here, if this is suppose 1 1 and 0 is the delimiter or the separator, and 1 1 is again the y part. So how your machine will execute actually. So just you can visualize the things in your mind by seeing this animation through the example. So you are in state q0. You are now you are reading this 1 from the input tape. Now you are reading to this 1, and you are moving towards the 0. Just see the animation part. It is very helpful for you to visualize the thing. And that again it is 1. Now you are in q1 state. Again in q1, this is the blank sign here, right? So this is the blank sign on state q1, and after that you are moving towards the left sign. Now you are reading 1. It is converted into blank. Then this is the final representation. Means all the delimiter or the separator is converted into 1, and last one of your input alphabet is converted into blank. So this is the simple logic behind this x comma y is equals to x plus y. Now the another example is, suppose fx equals to 2x, or if fn is equals to 2n. In this case, suppose n is equals to 2, then you have to write the answer, that is 4 multiplied by 2. If x is 4, then the answer should be 8, likewise, right? So just see the steps what we want to do. Just see here. In this case of fn equals to 2n, just the meaning is this x is suppose 3 or n is suppose 3, then answer should be 3 multiplied by 2, that is 6 should be displayed in the tape. Now just see here, suppose this is the situation, and then after the execution, this situation should be shown onto the tape. Clear? So the basic logic behind this construction of fn equals to 2n, just see here, replace every one by x. This is the first step. Just all the ones we have to convert it into x, right? Find the rightmost x and replace it 1 at the time of rightmost left means at the time of traversing back towards the left side, and then traverse to the right end of the current non-blank region and write the 1 there, right? So means if all 1 are converted into x and the rightmost x is converted to 1, and then traverse to the right end of the current non-blank region and then write the 1, and repeat these 2 and 3 steps until there are no more x. Means all x should be converted into 1. This is the simple logic behind the construction of the Turing machine for Fn equals to 2n. So just see the machine, how can we perform the this Fn equals to 2. So just see here. Here, suppose your n is 2, and after that there is blank sign here. So your answer should be, this is your input, and after the execution of the machine, what you want, your answer should be this one, right? That means n is 2, now it should be 4. It should be the answer. This is the final answer. So what is the logic? Just see here. You are in state q0, just convert this 1 into x and move towards the right. Means all ones should be converted into x. So just see here, all this is converted into x and this is converted into x. Now you are getting here blank sign. Clear? So now as you find the blank sign here, just write blank, read blank, write blank and move towards the left. Now you are in state q1 and you are reading this sign, this is q1, right? So in this x, you just convert this x into 1 and move towards the right. So this x is converted into 1 again, right? And now you are moving towards the right. On right, you can see here there is 1. Yes. So in q2 state there is 1. So this this blank. So this blank is converted into 1 because this is given to you, and the direction of head will be left. So now this blank is converted to 1. Now after that there should be more blanks. So this blank is converted to 1. First x is converted to 1, and now the direction is left. On left you are getting here x, right? So x is converted into 1 again, and direction is right. Now you are moving towards the right, and now on state q1, on state q2 you are getting 1. So no need to change this one. Just you have to move to the right. And after reading this blank, you just convert it into what? This just you should convert it into 1 and move towards the left. Now you are in the state q1, and now in the state q1 you are getting here 1. So on 1 you don't need to change it. Just 1 read, write 1 and move towards the left. Just we are moving towards the left. But at the end of this string, you will find here blank sign. So in blank sign means you all x are converted into 1. So now as soon as you find blank here, just reach to the halting state, that is final. And here you can use the direction of head, maybe in the right direction or maybe in the left direction, no problem at all, right? But fortunately you will reach to the final. So these input is 2, so these 2 inputs are converted into 4. So simply your output will be shown in this way on the tape. So this is the simplest way to construct the Turing machine for the typical type of problem. So this is the Turing machine for accept the language Fn is equals to 2n. So if you have any doubt, then we can discuss in the class. And another problem, that similar kind of problem you can say, we can also discuss the same thing in this manner. If Fn equals to n minus 1, Fn equals to n minus 2, you have to show the answer if n is greater than equals to 2. And if n is less than 2, the answer should be 1. Clear? So it is the important part. Just how can we apply the limit here? So just see how can we apply the limit. In this case, in this particular diagram, in place of hash sign is used in place of the blank sign, right? as I already told you that we can use hash or blank or this symbol. All the symbols are used for representing the blank. So these are the various symbols that can be used. So in this particular diagram, we used hash sign as the blank, right? So just see here. If suppose value of n is suppose 3, right? So how your machine can be performed? Just see here. You are in state Q0. After reading 1, you just move towards the right. So it 1 को read किया आप आगे आप. Now you are in state Q1. Now just check if you are in state Q1, then another one is there. If yes, then move towards the right on state Q1. So in this case, just you can see in these two steps, just I follow these two inputs. Means on one single one, we move towards the state Q1. On another one, we are moving towards the state Q2. So this is the basic restriction that we are going to apply on the machine, that at least n should be equals to 2, right? Now, what we have to do? Now, after that, just if just we have to the same state after reading 1, right? As soon as you find here blank sign, that means after reading this blank, just keep the blank and move towards the left side, and direction is Q3. So you reach here Q3. And then you find here 1, so just convert it into blank and move towards the left on state Q4. And after that, this again 1 is converted into hash sign and move towards the left. And after that, you will on the halting state. So the input number is 3. Then you will find the value, that is 3 minus 2. That should be 1. So here you will find the right answer. So this is the case if the number value of n is greater than equals to 2. Now another condition, if the value is less than 2, suppose this is 1, right? So in this situation, what we have to do? So you are in the state Q0, right? It's in this situation the answer should be 1. Clear? So just here how is it possible? How can we check or how can we verify the condition? So if it is 1, then you are in state Q0. If 1 is there, just read 1, write 1 and move towards the right, right? In right, you will find the blank sign. So simply on blank sign, just write, keep it blank and move towards the left or right, whatever, and you reach to the halting. So simple, 1 is the answer here, right? Because you never reach to this part, because in this situation, you have to require minimum 2 1s, right? Then only you can move towards the right direction for this part. So this is the simple way to construct such type of complex problem in a simple way. So this is all about the designing of the computable function. Thank you.